Welcome to our webinar, Vessel Seafarer-Centric Approach to Alarms and Cybersecurity, highlights from the Digital Ship Hamburg Forum in December. Our guest speakers today are Asger Schliemann Haug, Systems Engineering Specialist, Lloyd's Register, Dr. Anisa Rizvanolli, Team Leader, Maritime Scientific Computer Optimization, Fraunhofer CML, and Andrzej Gab, Director, Maritime Competence Leader, EY. If you have any questions about the topics today, please type them in the Q&A section and we'll get them answered for you at the end of the presentation. Here is our host, Carl Jeffrey from Digital Ship to explain more.
Okay, so we're tackling two big problems today, that ship crew get too many alarms and shipboard cybersecurity is not always managed according to where the real risks are. And also today we want to show that digital technology can look very different when presented from the seafarer or shipping company's perspective than from a digital technology perspective. So shipping companies and the crew want technology which can support their operating processes and help them manage their risks, and technology which is easy to understand and doesn't overload. But we also see that ships have too many alarms because the alarms are set up by manufacturers separately for each piece of equipment, and there's not enough thinking about the full picture of when it's useful for seafarers to hear an alarm. And cybersecurity is often thought about in the context of technology to fix a problem rather than what the actual risks to shipping companies are and whether they have the appropriate processes to manage them. So for the alarms, we've got a talk from Asger Schliemann Haug, who's a systems engineering specialist with Lloyd's Register. So he's going to present research into how many alarms there are on ships and how it can be done better. Asger is a former second engineer and watchkeeping officer with offshore company SVACT. He's got a master's degree in software design and data science, and he's based in Copenhagen. Then we're going to hear from Anisa Rizvanolli, team leader, maritime scientific computing and optimization with Fraunhofer, based in Hamburg. Anisa is going to explain how to get a real-life understanding of cyber risks on the ship bridge using actual bridge equipment installed in their laboratory so they can see how far a hacker can really get with it. Anisa has a PhD from Hamburg University of Technology, where she wrote a thesis on resolving ship crew scheduling problems. And finally, we're going to hear from Andrzej Gab, Director and Maritime Competence Leader with EY Poland. Andrzej is going to give a shipping company perspective on cyber risks based on hacks which have actually happened. So Andrzej is based in Warsaw and has got 30 years experience working in networking and telecoms and cybersecurity, and he's also the operational manager of EY Poland's Neurodiversity Centre of Excellence. And these are all short versions of talks presented at our Digital Ship Hamburg Forum last December. We're going to have the three talks about 10-15 minutes each, then there should be time for discussion. So you can put questions in the Q&A box at any time, and we'll take questions at the end, or our speakers might be able to answer them by typing while the other presentations are going on. So please put the name of the speaker the question is for so we know who should answer it. And I'd like to invite Asger to start his talk. Cheers.
Thank you very much, Carl. I'll put on the presentation here. Good. All right. So I'm going to present a little bit of research that we did. And I'll kick it off by having like an agenda here. And we'll start looking at the mega trends going on maritime, which is automation, decarbonization, and remote control and remote support. And we're quite ambitious in the maritime industry. You know, we want to really go further than we have done the last sort of millennium. And in conjunction with just going to remote control, autonomous ship, and other very data-intensive operations, we also look to tackle greenhouse emissions. And a lot of that work is about adopting net zero fuels like ammonia, hydrogen, and methanol. And these fuels are also far more hazardous and complicated to handle when compared with traditional forms of diesel. So these data-intensive operations, they will require careful consideration to security, particularly cybersecurity, which is especially true for remote control and monitoring. And likewise, you know, when exceptions occur, because you can never design with complete knowledge, we're going to still rely on human operators to provide, you know, informed decisions when they respond to these exceptions. And we have a vision of a person sitting very poised and relaxed and feeling in control of all the information flowing to him or her. And what is the question that I would like to all the viewers to consider is whether we will currently look at such a picture, whether we have a more situation where a bit like an operator feel a bit like more like Homer did in the nuclear power plants in Springfield. So that merits very good to the NIST framework, which has a detect and respond and recover parts in its life cycle. All right. So just to brief quickly what an alarm definition is in this presentation, and I try to put it really in layman's terms, it's like some communicated message to someone about something you don't want to happen, such that this someone will hopefully respond and intervene before it happens. That's an alarm in its nutshell, basically. And we can take an example, which is from not the maritime domain, but I think an example that many people will understand. And that is like a forward collision alert in a car. So if we take a distance forward to the car, and we have a process variable on the y-axis and time, we see that the distance, if the car in front of you broke very hard and you didn't see it, that distance over time will become smaller and smaller and smaller. So we're gonna have a consequence threshold at some point, which is what we don't want, like a collision. So many modern cars today, they have like an anti-collision alert system, and it gives you a set point when it can see that the rate of change or your proximity to the front driving vehicle is getting too close. So you get an alarm, which is the low distance, but there's like this acknowledgement delay. There's like a little bit of delay before you see this alarm. So you go, oh, what? Oh, and then you start to react. There's a little bit of reaction delay before you actually see the alarm and before you then finally react, and you press the brakes. Maybe you also pull the handbrake if you have an older car, or the like, or maybe you try to even steer around. So there's a set of discrete actions that you complete to do, and that takes some time. But then the car doesn't stop instantly. There's a process dead time. The brakes need to make friction on the brake discs, and before actually the car starts to accelerate, there's a process dead time. And then hopefully the car will start de-accelerating in due time, that the process time of the acceleration, or what we could say, the time where now it's the system and not the human anymore, still makes it so that you avoid the consequence threshold. And once you have achieved a little higher distance than the alarm set point was originally, that's what we call a hysteresis, the alarm tends to clear. A quite important topic with dealing with alarms is that this total process response time is something that this is defined in the design process. So if you put tiny brakes on a car that's very big, this time is going to be quite long, right? Or if you put huge brakes or race brakes on a small car, this time is going to be very small. So that is definitely something that designers can influence. The other time aspect is this available operator response time. And this is why we have general guidelines like you should keep at least 2 times the tachometer distance to the car in front of you, because they recognize that it will take time for you to detect, respond, and brake and press the brakes. So in total, the time is pretty critical for an alarm. If you didn't react, then we get these type of accidents. Good. So this alarm was actually, I think it came in about 10 years ago from some of the more premium makers. But up to that point, the automotive industry didn't really engineer the problem. So back then you had to use your own eyes. But today many have them. So this is a good example of risks that can be dealt with at the design stage. So today many cars are capable of avoiding a collision, even traveling with 100 kilometers an hour. So it's quite fantastic. Okay, so how many alarms can a trained user deal with? Well, it's certainly true that the limits to what a person can take in is not based on the alarm system's rates of printing alarm messages or flashing lights. It's the human. Basically, beyond 10 alarms a minute, it goes really down fast. Then the probability that the person sees and responds drastically falls. Good. So this curve is very old. It's back in the day when there was unique lamps for each alarm. So again, the people in the audience could ask themselves, what should define a good performance criteria for alarm systems, and whether or not that is the rate at which it can inform the user, or the rate at which it allows the user to detect, diagnose, decide, and respond to the alarms. And I would say that the answer is probably the B. Good. So what is the state of current affairs? Well, in the Q3 and Q4 2023, we went out with Lars Vista, and we asked around 65 watchkeeping seafarers on their opinion of the alarm system usability. And there's a distribution plot there that people can see. We did this on different ships, as 15 different ships, all from diverse range of segments, from cruise ships to chemical tankers to tugs, old ships, new ships, ships that are 32 years old, ships that just were launched 2 years ago or 1 year ago even. And we did this from what we call a critical sampling criteria, meaning that we went and we asked high-performing companies because we wanted to understand what works well. So that's what we did. And we were also giving a lot of data. We got 12 years of all the alarm and event data from these ships as well. So we have quite a lot of objective data as well. Good. One thing we noticed is particularly for even ships that are certified with integrated bridge systems and enhanced navigation awareness, meaning that's actually certified for one person to be able to sail this ship alone on the bridge, is that they get quite flooded with alarms when it really matters. So, for example, passing through the Strait of Gibraltar, we observed at right at the midpoint 77 alarms going off of the bridge for that 1 hour. So that's equivalent to having to go to a given position on board the ship and read and understand and acknowledge it and decide what to do with it more than once a minute. In the same time, in the engine control room, it was about 144 alarms, so a little bit less. And this was, of course, for quite a new, quite advanced cruise ship. Yeah. So the officers on board, they cannot deal with that amount of alarms at all. So they get quite creative. They get the tapes out, so to say. But some of the new equipment have the speakers, very deep in, so they cannot even sort of mute it and ignore it. But that is a very common observation overall, also for some of the older ships. This is an older ship. The ECR is even worse, I would say. What we experienced on a lot of the cruise ships is that, on a bad day, you could have 20,000 plus alarms, and you can actually have so many alarms that it's impossible for the user even to acknowledge all of them. Yeah, so here you can see the curve from the same ship. And the periods here just where there's no alarms, they indicate simply just missing data. If we think about a human phenomenon close to your own life, you could imagine if you got a false phone call around once a minute, what you would do with your phone. but there could be a life and death call in one of those many calls. But the truth is that the human operators, when they get very used to it, they switch off. So they actually don't use the alarm list or even the alarm annunciators really. Yeah, they become like Homer, critical what you could say. Alarm floods, even for old vessels, is also a problem. So we visit also some really old ships. And at some points, they can have alarm floods where they get 200-300 alarms at once, because everything is coded or configured like single input, single output. So everything just lights up at once. And this is quite a problem, which has been identified in other incident reports where, for example, the Stena Scandic incident, where for 45 minutes, the operators, actually, the watchkeepers didn't know that they were not getting power from the emergency switchboard, because the information was there, but it was flooded in the alarm monitoring system. And it makes the watchkeepers feel a bit like this when it goes on. Yeah. So what do the seafarers say? I'll just put on a little bit of the quotes that we got. Again, the presentation will be available to everybody, so I'll try to just move this a little bit fast. But to say the least, when the seafarers here have the opportunity to be anonymous, it was quite evident that there was a room for improvement. Also, the bridge officers find the alarms more annoying because they need to actually manually control the vessel. so they need to do something manually, whereas an engineer doesn't need to sit in the engine control room and hand tune or regulate the frequency on the switchboard or the amount of cooling water flowing to an engine or something like that. It's more closed loop control, but on the bridge it's more an open loop context, and that makes it even more distracting. One bridge officer, he said that they would need a new position on board as an alarm officer in general. So they feel a lot. We didn't have any respondents of the 65 seafarers who said that they wanted more alarms. Let's just put it like that. Also, alarms are hard to understand for the people. Sometimes they have to be coded by a control instrumentation engineer who has maybe not sailed in the real life or doesn't really understand the context. And one bridge officer said that all the machinery alarms he gets means call the plumber to him. So in general, it can be quite hard for the people to actually understand what is expected of them from all these alert messages that they get. And also the rate of it is that actually 38% of all the engineering watchkeepers said that at times they actually had to force and accept alarms without actually having time to read and understand the given alarms. Yeah, good. Overall, we do a lot in the maritime. Now we install windmills and we install sails and lubrication of the hull, like air bubbles and these kind of things. And in general, the people on board, they felt that definitely more attention could be given around the management of the overall alarm system to help them improve operations compared to also all the other activities going on at the moment. So if you're a ship owner that cares a lot about how your people experience sort of engineered seafarer well-being, alarm systems are definitely appears to be a good place to look. All right. So the destination is that other industries have actually pretty hard criteria for performance. You see some of the performances that you maximum give 12 alarms an hour in like the process industry, and other industries also even have a criteria for the minimum time that should be available for a person to actually diagnose the problem, but also for responding. Something that we don't have in the maritime industry at all. We also maybe tend to have a little bit of a policy patch tendency in maritime industry, and also from the equipment manufacturers, like Carl said, that if we have a situation that we cannot engineer out, we propagate that on to a human on board, and then we make an alarm for it, and then like, yeah, job done. And I'm going to invite, of course, the two other speakers to consider how to alert the crew on cyber incidents on board. It's quite a good analogy to think about. Good. For the people who are interested in the data set, there is a link here. It will be open source, and there's also a report currently in the making, which is quite far. And here we share also all the source code on how to analyze your performance, your quantitative performance. So if you have those capabilities, you can show it to your data scientists in-house and give them the alarm log, and they can basically work further with it. Yeah, so that's, we share, we care in alarm. So that's the main idea with it. Good. That was my presentation.
Well, thank you very much, Asger. So I think that shows the shocking situation, and as shipping gets more and more complicated, this problem is going to need to be fixed, I think. So now we'll go to from Copenhagen to Hamburg. We're going to hear from Anisa Rizvanolli. So we're going to present cybersecurity, maybe more from a shipping company perspective. And Asger, you see there's a couple of questions in there already for you in the Q&A if you want to have a look. But we'll pass to Anisa. Cheers.
Yeah, thank you, Carl. So I think you can see my screen. Well, we have heard a lot from Asger regarding all these alarms and how to deal with them, but maybe in the cybersecurity topic, maybe we should talk about how to get at this alarms and see and treat the cybersecurity topic in the maritime domain. I've brought with me maybe for everybody in Germany, most of them know Fraunhofer, but there are some international guys over there. I've seen that maybe I haven't heard about Fraunhofer, which is different to LR. Well, we are one of the largest applied research institutes in Europe and have different institutes. We are 30,000 people and deal with a lot of different topics. The Fraunhofer I'm working for is Fraunhofer Center for Maritime Logistics. It's located in Hamburg, and we do a lot in the maritime domain. So we are very, very maritime domain focused and try to help the maritime industry to fill the gaps and improve themselves in different topics. One of them is cybersecurity. And we work in different domains, like for the hinterland, we do a lot of analysis and optimization. We have a department that deals a lot with unmanned shipping and autonomous shipping. Ship and information management is the department where the topic of cybersecurity is located in. We do a lot of digitalization and optimization stuff for the shipping industry, and we have one department that deals with port technologies and how to use AI to improve and automate port operations. Just a few introductions, and then I move back to cybersecurity. So why cybersecurity? Well, maybe most of you know, okay, we have a higher connectivity nowadays than 10 years ago on board of a ship. It's becoming cheaper. People are bringing their own device, like everywhere in the world, on board. And you have a higher intertwining between the operational technology and IT, which 10 years, 20 years, 40 years ago was like very strictly divided. And now they are together. And this, we have a higher automatization, like machinery. We have we use more optimization software, more decision support through different automatization software. We put IP and serial networks together and are moving toward decision support system and unmanned shipping or autonomous, partly autonomous shipping. And this all opens the door for more cyber attacks. So we are highly connected. You have a lot of devices that you do not really control on a single point. And you have a combination of different networks on board that where you have to take very much more care about their segmentation than 10 years ago. And on the other side, cyber attacks in total, they are increasing. We see a higher frequency and they are more costly. And it is not like that, like the ships are the main target. Sometimes they are just hit on accident. And as far as we know, there is no real insurance coverage when you have a cyber incident. And one must keep in mind that ships have a relative long lifetime. So at the point of time when ships have been designed like 20 years ago or even 40 years ago, cybersecurity was not a main required aspect to be taken into consideration for all the systems. There were other aspects where people were focused on when they designed a ship, like the safety and security, but cybersecurity was not one of them. So we have a lot of systems on board that were never designed to be highly cyber secure. So we have to take other measurements for different ships on their different ages and steps to make sure that we consider cybersecurity. Well, and as I mentioned, like we have the different ships, and for the ones that are existing now and are quite old or relatively old, the IMO presented this idea of putting the cybersecurity operational countermeasures on the safety management system, so that everybody should have like a plan what to do if you have a cyber attack. And their main target with this idea were the existing ships. It's an operative measure, and we see there that this is still they have included the main countermeasures that they need to do in their safety management system. But we see with a connection to our partners, shipping companies, that it's still a lack of awareness among the seafarers, which makes it very difficult to implement all the operational decisions. And we have the second part where the target are the new ships, and the system manufacturer are all these uniform requirements, the EE27 and E26. They're coming to life, so they should be taken into account for every new build after middle of this year. And E26 focuses on 5 central requirement categories, which are identify, protect, detect, and respond and recover. But we have the current situation looks like this, that we have like these regulations describe what to do, but they are not very specialized in describing us how to put it, how to make it work in such a very different and diverse environment like the shipping industry is. And there where we, at Fraunhofer CML has decided to go this way, to build up a kind of laboratory with real bridge equipment. And where you have the possibility to install new devices to see how they react, how secure they are, how one can connect them with the other devices. You are able to change your network topology to take a look at how secure is your segmentation of your networks on bridge of the ship. And of course, you're more like free to develop new approaches instead of testing them on existing ships that need to run their operations safely, where you can not really put hands on and change all the segmentation or the bridge equipment. One of the ideas is to do risk assessment, so to perform attacks on this laboratory, real bridge laboratory, and to analyze the system behavior, and then to create new countermeasures on a technical level or maybe just on an operational level. And one of our main aims is like to validate awareness. As I mentioned, this is one of the pain points currently existing in the shipping industry, as many of the seafarers are not like IT guys, and they don't have to be. But but that's why they're feeling that they need training on advanced digital technologies to take a better awareness, a better feeling what is really a risk and what is something that you can neglect. And this is what we have thought to use the laboratory for, to enable training in real-world environment and to make a higher impact and focus on the most relevant topics instead of doing all this kind of webinars and learning webinars where everybody's like checking. Yes, I have heard about cybersecurity, but when it comes to the real world, then they're still lacking the awareness. And at the end of the day, you don't really do a fire drill on a computer. So it's easier for the people to keep in mind what's the main key point of cybersecurity if they do it in their real world environment, rather than if they just check the webinar on the computer and do the training there. Well, the bridge equipment is full, so this bridge is like one part of the bridge is here with the actis and radar and VDR and all what you need or what you normally have on a ship bridge, on a normal cargo ship bridge. And we have the second part, the antennas, which are on top of our buildings with all the radar and so on. And what we try to do is like system monitoring to do based on risk assessment. We have developed together with one Fraunhofer in Bonn, which is doing a lot more like tools in cybersecurity, intrusion detection systems, and to try to detect differences between normal behavior and incidents, so that in order that we are able to make the right alarms and not like putting another system that creates another million of alarms, as Asger said, and nobody will profit from them. They will just feel distracted, and maybe we'll see too late that something has happened. And what we do with this laboratory is we also collect real data for better monitoring and to validate the response to the approaches and conduct tests and preparation for the worst case scenario. So either with the seafarers or by developing different tools and making sure that we understand the technology behind the devices and give some kind of well-informed risk assessment, instead of just saying it's secure, it's not secure, you can get an email or you can get a phishing email, making more dedicated to the bridge equipment, dedicated to the OT and IT on board the ship. Yeah, and that's basically all for my side. I'll be happy to discuss with you on the different questions and ideas that you have. Thank you.
Well, that's great. Well, thank you, Anisa. So that's a perspective on how we can understand shipping risks from a shipping equipment perspective. And then I think now we're going to hear more about the threat side, I think. So we're going to Warsaw, going to hear from Andrzej Gab, who's going to talk about how the what the threats look like. So I'll pass over to Andrzej, cheers.
Hello. This is Warsaw from the site. Happy to connect with you. From my perspective, it will be some work on cases, and just for the start, short disclaimer. But for the shortened presentation, it consists of some models. So please don't attack me with some details. Of course, you could be right if something doesn't happen or it won't happen. But it is more about to start discussion and start interaction with you after the presentations during the Q&A part. So let's start. So what we see and what we treated as a cybersecurity guys, we can consider ship as a floating factory. As you can see, there are some systems working on ships, and they are controlled by PLCs, some computers, some controllers, and so on. And they are very, very similar to the factories you can find on the shore, producing some for example, pharmaceuticals, some other products you can see. But what is special with ship treated as a factory, that this factory moves geographically every time, every day. It could be in other geographical place. So if you imagine someone who is responsible for cybersecurity of the factory, he couldn't just bear with some situation that one day factory is near, for example, Hamburg, and the next day it's near to Antwerp, and the next day is near to London, and next day is near to Barcelona. So every time it changes not only the geographical place, but also the law it is going under, some other systems around environment and so on. So it is a model, but I think it shows you some complications, some advancements of maritime infrastructure and maritime cybersecurity challenges. So what could happen with such factory on a move or on the move? So let's imagine there is an email coming to the port, because it is not only about ships, it is about all maritime and also about ports, terminals, and so on. So there's an email requesting participation in just a survey. So we participated. Our computers started to tend to be a bit slow. Oh, it's okay, sometimes happens. But we can observe that there's an increased amount of external traffic. We are trying to check, monitor what's going on. But for example, one time, one gate opened by itself and cannot be closed. Why is that? So what should we do? In that moment, if the gate is open and it should be closed and should be open just for a just limited time, because it should be controlled, we send a guard to check and to be kind of guardian for the gate open. But next hour, all the port gates are open, included the bonded store. So it is kind of emergency situation, because bonded store couldn't be open. It should be closed and just limited with the transfer between the zones. So something strange is happening. Something we should keep eye on, and we should check why the port gates are open and when they couldn't be closed, and what has happened. But the next minutes, ID cards started to not to work, and our staff persons can't enter the building. So we are stopped with any activities that could help getting out of the situation. We are getting into troubles more and more. And there, in 15 minutes, power supply problems, trays don't work, all the normal activities, normal work stopped. So it is a quite big problems now. We are trying not only to manage situation, we are trying to communicate the leadership, our management, and maybe outside first party working with us, that we have problems and there is an emergency situation. it happens that a small fire started in port facilities. So we call the fire brigade to stop it. And port community systems doesn't respond. Cargo documents cannot be printed. So all the activities in port are stopped finally. And there is a kind of disaster. Oh, that's why. Because we see that there's a ransomware requesting some ransom from us. So we know why did it happen. So could it happen? Could it happen in real? We believe there is a possibility, sometimes quite high possibility, that such situation in port facilities, in terminals, in other places in maritime, even ships, could happen. Of course, maybe in not such quite fast and quick way. Of course, there are some stops implemented in the processes you have, but if someone knows what is your business logic, someone knows how many things work in maritime business, they could prepare such a scenario that such situation could happen. And it did happen. Maybe sometimes it wasn't planned. Sometimes, like in Maersk situation, it was just a ricochet. But some of ports, some of vessels were hit by ransomware, and there were stops in activity, in normal production, normal work. So it's all connected now, and we cannot just disconnect things. So all the things in ports are connected. Ships coming to the ports, they connect to PCS. They can connect between each other. There's a ship-to-ship communication. They can transfer data. They can make such sometimes not fully controlled transfers that can be kind of dangerous. There could be possible malware spread, especially in the ports, which we consider as a hubs, which is very good. Ports are hubs that could do the good work, but at the same time, it could, if it is not protected properly, in the ports could be possibly malware spread. And the impact is full widespread service outage impacting multiple ships, multiple port systems, and there could be even further lateral movement, many systems infected. So the problem is very global. We have prepared some map, we can say, of last 7 years incidents, and big incidents only. You can see here NotPetya, which hit Maersk. You can see here MSC malware attack. You can see also last DNV, but we haven't put here last Australian things on this. But every of these attacks impacts were very high and financial very awful. So it is not like it happens from time to time and it happens to the other guys. It could happen even to us. And I believe we should be prepared for that. And as cybersecurity is a process, not a one-time decision or one-time implementation, we should be prepared with our processes, our people, and our solutions to that. So we know that your sector is very unique. We know that it's different than factory on a shore. We know that it's very different, even different from oil and gas industry, but you work very heavily with oil and gas. There is no direct chain. OT in maritime security, PLCs, all the systems are very, very unique, and they have there are some implications about responsibility and maintenance, and there is a very long upgrade process and updating process. So there should be some processes prepared for maritime cybersecurity. We understand that. If the ship is far away from shore, there are only satellite links available. Now there is a Starlink coming into this business in some areas like cruises very fast. but I believe in a short time you will have Starlink almost everywhere and communicating with very broadband communication, which extends risk surface, which means that you will be hit with more and more attacks per hour. So there are some problems with maintenance. Yeah, we understand that too. So we've got some real questions, and these are real questions open to talk with you, to resolve. And I believe some organizations need to resolve on their own with some help. About responsibility between IT and OT, some awareness about cybersecurity, about maintenance procedures covering cybersecurity too, and so on. So coming to the end, I would like to leave you with a global call. So what is our business message to maritime company leadership? We should talk to let them understand the importance of this area, cybersecurity area in maritime. And it concludes my presentation, shorter presentation for that moment. And I would like to talk with you about cybersecurity. Thank you.
Well, thank you very much, Andrzej. So just invite everybody to turn the cameras on, and we'll try to summarize. So there's many different issues coming up. There's quite a lot of questions in there. A lot of them are very sort of specific things. I thought perhaps I could invite you to comment on each other's talks, perhaps if you invite Asger and then Anisa. So Asger, what do you think, sort of summarizing? I mean, there's obviously a gap between what the shipping company need and what the technology sector as a whole is providing. And we've gone into lots of different areas. And as a general point is how on earth we fix these big problems. I don't know if you have any other comments on what you've heard on the cybersecurity side, do you think?
I think the biggest challenge is that the NIST framework has this, identify, protect, detect, respond, and recover, right? It's almost like an alarm management in a different package, so or a risk management framework, right? So, but it's a good framework. The challenge is this, detect phase, and also I think identifying the risks are easy, and it has been done in many other industries. But to the systems or the attack surface, understanding the real business impacts. So what does it mean if we get a penetration here? What does it mean to safety, or what does it mean to our business? That is something that the cybersecurity industry needs to work more on, because just because somebody gets into a network doesn't mean that necessarily it's detrimental. Because we got segregated networks, so maybe one network is compromised, but it does reduce your availability should the other network fail for some reason. So that analysis has to be more thorough, going all the way into endpoint, not just so now we're in the network. Okay, we're done with the risk. Okay, then what? That's my encouragement to the cyber risk guys. The other aspect is this alerting phase, or the respond and discover on ships. Unless it's a very advanced cruise ship, you don't have IT savvy guys on board. So you cannot, and as you've seen here, the amount of alerts and the amount of information propagated to the humans is already really big. So you need to be very careful when you design your alerts, that you have a very defined response, what you expect, and that the person has the utility or the resources to do it, and that the person knows what to do, and that the person also has time to do it. So getting these 4 quality attribute rights right for the people on board is absolutely key. And I already seen alarms being provisioned in the new IAX URs 26 and 27, where even if a port on a switch somewhere is all of a sudden unblinked, it should also give an alarm. And I can just imagine a future where if you restart a network or something like that, how many alarms you're going to get flooding into the system. So we should really work to be very contextually aware and suppress alarms when they're not relevant to the user, because otherwise it will be like the wolf cry, like the boy who cried wolf. And then the day it really happens, they won't really respond to it because they're numb to it. But on the other hand, we also cannot rely on them filtering that out from the text screen. So in our presentation, I showed this huge screen was all red. You know, these screens are not even on, even though they have 6 big monitors in the engine control room on the bridge. This alarm list is not there, so you can also not just print it there and expect people to see it. So maybe you need some kind of other lamp or another indicator, and then a very defined response, or at least pointing to a procedure.
Wow.
That's my takeaway.
Yeah, I was just reading the questions. There's a bit of a theme emerging in nearly all the questions about we need more precise modeling about what can actually happen. So maybe I'll just try and summarize. So Mike Powell from Cardinal Maritime is saying we can map out sort of fault trees for the whole system. Dimitri Liras is saying, shouldn't the focus be the which aspects of automation can be prioritized? Christopher Stein from Royal Caribbean is saying maybe increased collaboration along the industry could help understand this better. And then in the sort of understanding on the answer question screen, we've got JD Voira, who's from Bari Ship Management. He's saying maybe class could list out which alarms are important and which aren't. Christopher Stein is saying about integrating cybersecurity into courses. I guess it's a different point, but consequence-driven engineering he's asking about. I guess that's sort of mapping out what can lead to what. So maybe if we go to Anisa, I mean, I guess this is exactly what Fraunhofer is trying to do here, is sort of get much more precise understanding of where the...
Yes, and I fully agree with what Asger said, that we need to take a deeper look on which system are most important ones, which are the ones with the highest impact in the operations. And make awareness. I mean, really that depend even in the land, on the land side. So what we do IT, normal IT, the guys are just exercised. They know how their system works. They know what they expect, so they get a good feeling. And there is no feeling for that, or not really a good experience where you can build upon up for this topic. It's relatively new, very broad. Everybody has an idea of that, but you need on a ship a very specific aspects. And this needs to be done on different levels. So in the design, in the very early design, okay, we're addressing it right now for the new builds, but we have all this other old stuff that has to live with that somewhere. For them, you need another to address or focus on another aspect a little bit. But awareness would anyhow help in any case, even for the new ones, for the old ones, and for the ships that are middle-aged now. So that's we need to address, and that's why we thought, that's why we developed this lab, so this real-world bridge lab to do hands-on on that, and not only doing theoretical cybersecurity and research, but also like really applied stuff, and see where the pain points are.
Oh, okay. So to Andrzej, but the question about understanding the risks, in my mind, there's sort of one set of risks which will involve getting hold of somebody's username and password and what you can do, and then there's another set of risks about hacking into hardware, because we had this discussion before about hacking into a train in Poland, didn't we? And that's been proved possible, so we can't say we can't hack into a ship engine. How do we sort of classify the risks, do you think, or is that helpful?
Okay, so there's a plenty of risks, Carl. So we could spend even 2 weeks enumerating them all. So it's not only passwords, not only breaking into PLCs controlling ship motors, engines. So if there is an electronic or IT system or OT system, there is always risk. It will be hacked, or it will be used in not proper way. So of course, sometimes it is like the risk is like robbing the Fort Knox, but it is still, yeah. But in many times we see in our experience that the systems are not properly protected. It is not only about firewalls, not only about some specific systems protecting, but it is all about processes. It is about all monitoring devices, all monitoring of devices. It should be implemented, and reacting some incident response processes should be implemented. So yes, there is a risk. There should be a business impact analysis about the risk for every asset you have. and you should monitor, and you should recheck and do this assessment very regularly. Sometimes once per year, sometimes even more often. Yeah, so yeah, that's a short. But about the train case in Poland, I believe all of you should be aware, should be accustomed about this case. It is called NEVAC case. If you find on YouTube, it is Polish Trains or NEVAC. There is a Polish hackers group which helped to find vendors locking system for the engines and other systems in the train that were implemented by the vendor to stop activity. It is very good for your learning about cybersecurity and what could happen if there's a vendor locking.
Wow. So maybe for the last 10 minutes, if we come to Christopher Stein's question about training seafarers in cybersecurity, because I mean, there's a background that seafarers are completely overwhelmed, as far as I understand. Everything is far too complex and probably reached the limit of the complexity we can handle, and the alarms talk gets this point across. I mean, I think we'd all like to see cybersecurity handled away from the seafarers, so seafarers don't even have to think about it, but that might be a bit of an ideal. But perhaps if we go to Asger and then Anisa, what's your thoughts? I mean, you've already answered the question to say, well, maybe it would be good, Anisa, you said, but yeah, how do we make sure it doesn't overload the seafarer? That's maybe Asger first. Yeah,
it's a good question. I think one of the aspects is probably the manning criteria. So we have a tendency to just try to shove more stuff down the throat of the people that's already there. Maybe the industry needs to recognize that new skills need to enter the industry, and that more IT and OT, or I would say automation and instrumentation engineering competencies are needed. Maybe we need to define different types of officers on board for the future. Simply said, I don't think that, well, for example, that cyber, that this is something you can teach a traditional seafarer. I come from a traditional seafarer background, and doing a major in computer science is something very, very different. So if we intend to propagate a lot of the problems to a seafarer, instead of dealing with it at the design phase, which is then going to make the design more expensive, of course, right? We probably need to look at the overall competencies needed. Yeah.
Well, I mean, you're a seafarer with an MSc in software engineering, but we can't expect all seafarers to have.
No, we can't. And it was a really hard degree, so I also wouldn't encourage anybody to try it out just for fun. But yeah, it is very different.
Well, Anisa, you want to add anything about what seafarers could...
it's more or less the same. I think that makes the difference. So if you invest in the very early design phase and take into account different aspects, then you don't really need highly specialized or dedicated personnel at the end of the day, but just different maybe a different learning system for the seafarers. But yeah, that makes them more expensive. So. But I think at the minimum level that you need for the new stuff to get it operated safely, it's a little bit higher than it was like 40 years ago, and that needs to be addressed anyhow for everybody. And the manning question is also a good question. So like if you want like only cheap and a reduced number of manning, then you cannot expect high quality, like people knowing everything about cybersecurity and being aware of that. Sometimes it's not really studying as a computer science, it's just the awareness. And if you don't really understand how the main principles of the systems are, you cannot really build up awareness in a sustainable way. And that's where we have to change maybe the way people are taught.
Oh, that's great. Well, maybe we go to Andrzej for the last word. So there's a question come in from Jan Soller. I saw Jan Soller on LinkedIn from Fraunhofer. It may be him, but he's asking, he said there's activity on the dark web where services are offered to spy data from a ship, or I guess they're selling spy data from a ship who is working here to protect. And maybe you also had the comment before we started about shipping industry trusting its vendors too much compared to other industries you worked in. Do you want to elaborate a bit more on on that point? I don't know if you know anything about the dark web for shipping, if that's something you've...
As you can see, if there is something to be sold on in dark web from ship, there are some ships facing their systems to internet or facing the systems to public network. So if someone got into, maybe they have good stuff to sell. I don't know if it's real. Sometimes it is just honeypot, because we cannot say it couldn't be just just a honeypot to get some hackers into. But we have checked we have done some research, so we can see some systems that are really connected to the internet, and would like them not to be, because it is very, very, very risky connect such systems, even if it's kind of office network on the ship, on the vessel, if it's even some not important network, but it could be a danger for the ship, even just to spreading ransomware, spreading to for example, to the smartphone of one of the staff from the ship, and then this ransomware could be spread to the other network connected to this on the vessel. So it should be monitored, it should be disconnected, or should be checked very properly.
Oh, any comments about trusting vendors too much? Is that you want to say anything more about? No? Okay.
I can maybe try to elaborate on that.
Yeah.
So, the vendors do the best that they can, right? I think that the challenges are more systemic than pointing simply at vendors, because vendors need to design systems to be decomposed and capable of functioning totally independent of basically many other systems. Sometimes vendors, they don't even know which other vendors will go on board the ship in the construction phase. It's something that the shipyard keeps a track on, and who wins the tenders and these kind of things. So in a way, vendors have to design their systems to take into account stuff that they depend on, and there's not a lot of thought giving into actually integrating the systems. And when I say that, is I say engineering integration, not just connecting them with a network, but actually integrating the systems across the entire platform of the ship. So therefore they have a very compressed phase of building, and therefore they need to propagate all these alerts further on because the humans are like the glue, they're the missing sort of integration between the systems. And we build ships maybe in a series of 8, whereas if you build airplanes in like series of thousands. So you can also spread this in integration cost on far many samples in other industries like aviation. So that's one challenge that the vendors face. And it's also that they face, I would say regulatory, even class rules and regulatory performance requirements, where there are requirements for alarms, that you put the alarms there, and the certification is very expensive to do. So it's all, and it's also rules that say even you just touch a little bit of the software, a little bit of the set points, a little bit thing, you need to redo an assessment. So you end up in this like certify and forget type of issue, where the adaptability of the systems, become constrained. So I wouldn't say that it's the vendor's fault because they operate in a quite adversarial setting in a new build phase. I think it's more a systemic challenge where all the stakeholders need to work together. Yeah.
Oh, well, that's great. Well, we're coming up to our time now, so thanks ever so much. I think that's we've given a great view on what needs to be improved in this gap between the shipping company and the technology. We're going to try and stick with this theme for digital ships. So Dimitri Liras, who you saw asking questions, he's going to talk at our next one on February the 20th about software, how software can work better for the shipping processes. And it'd be lovely if we could tackle this complexity problem. If anybody has any thoughts, please let me know. But I shall pass back to, thank you very much, Andrzej, Anisa and Asger, and I shall pass back to Farah for the closing words. Cheers.
Thank you very much.
Thank you. Thank you very much.
Have a good day.
Yeah, you too. Thank you.
Thank you, everybody.
Thank you to our guest speakers, Asger Schliemann Haug from Lloyd's Register, Dr. Anisa Rizvanolli from Fraunhofer CML, and Andrzej Gab from EY and to all our viewers. We'll be sending you a YouTube video link soon with their contact details if you have any further questions. Join us for our next Vessel Performance Info webinar on the 25th of January, Visibility of your EU ETS Exposure, which you can book online at our website. Goodbye.
Bye-bye.
Goodbye. Bye-bye.